And a healthy functioning soil, as I showed you with the minerals that are in the soil, has no need for synthetic fertilizers or inputs because everything we need for life or for plant growth already exists there. I used to come to conferences just like this when I first got going, and the best thing that I did when I was at the conferences, the speakers were always really great, but a lot of the time they were talking over my head. But the best thing that I did was walk around and shake people's hands, talk to people talk to people at the table and start building a network and a community and people that you can text and say, hey, I tried this idea, or are you going to the Saskatchewan Soil Health Conference? Start building a community because it gets a lot easier and a lot more fun when you've got somebody else that has similar interests and ideas as you and actually implementing them on their farm. So as Keegan said, my name's Joe Gardiner. I farm with my wife, my brother and his partner, and my parents. We have a mixed grain and cattle operation in Clearwater, Manitoba. Before you roll your eyes at me and say, in Manitoba, the soil's this deep and it rains once a week. I'm from the southwest part of the province, so it honestly looks a lot like here. There's very variable land. Used to be lots of bush, but the grain farmers are starting to take that down. But about 10 years ago, I wasn't having a whole lot of fun farming. We were a conventional grain farm. There was a movement that was going on. I'd gone to a few conferences. I'd been introduced to a guy by the name of Gabe Brown, and what they were saying made a lot of sense to me. So I had gone to university. I came out tens of thousands of dollars in debt, and it turns out nobody ever taught me how to grow a plant, what a plant needs, and how the plant, the soil, and the soil biology work together as one. So we made a switch about 10 years ago. We went full soil health, regenerative, whatever you want to call it. But this is why. So I saw this graph about the same time, so it does need to be updated. This was done by a guy by the name of Darren Coleman. He's got an excellent book. It's called Civilization Critical, if you guys are into reading. Anyone seen this graph before? So for the people that haven't seen it, this is 100 years of Statistics Canada data on farm profitability. So we've been told for 100 years, produce, 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 produce. The more you produce, the more you get paid. The more you get paid, the more money we make. Anyone guess what that green line is? Net farm income. So I was born October 8th, 1987. From that date till now, for every dollar invested in farm has yielded a 2-penny return. We have a problem in agriculture, and this explains 99% of it. The biggest problems in agriculture are no young people, or not a lot of young people are interested in agriculture. Who's here under the age of 40? Nice. Who's super excited? Please raise your hand if you're really excited about looking at this graph and this is your future industry. So the reason I start all of our presentations with this graph is because when we talk about cover cropping, soil health, plant diversity, regenerative agriculture, whatever you want to call it, we're talking about a systems change. A change in the way you see your farm and you see the way plants grow. And change is scary and hard. But the argument is, how much longer can we keep doing this? We have very few young people that are interested in agriculture, and we have less that are in agriculture and don't have off-farm jobs. My argument is this is ripe for change, and yes, we are going to talk about change today, but the status quo just is no longer we're going to be able to put up with. So we got to start here. We're going to start with a little bit of concept, a little bit of science. It's not too scary. 96% of a plant. Again, I have a very fancy education in agriculture from the University of Manitoba, and nobody ever told me this. 96% of every plant on planet Earth is made up of carbon, hydrogen, and oxygen. Carbon is a byproduct of the most wonderful chemical reaction on planet Earth, which is photosynthesis. We can take atmospheric carbon, energy, turn it into liquid, I say we, plants, turn it into liquid carbon, and that is the backbone of life. Everyone in this room, every living organism on planet Earth has plants to thank for converting atmospheric carbon into liquid carbon. Hydrogen and oxygen. H2O. Water. How is it that in all my life in agriculture, before I came into this realm, nobody ever told me 96% of a plant is made up of sunlight and water? And also, why did nobody tell me that we can, with management, capture sunlight more efficiently, infiltrate rainwater more efficiently, and hold it in our soil?
Because those are free. That's why they didn't tell you.
Oh! You sure you haven't seen this presentation before? Could it be that the 4% is billions and billions and billions in industry, and the 96% we can access totally free just with management on our farm? So what I hope to get across in this presentation is, how do we maximize the 96%? How do we wake up in the morning, go to work on our farms, and have that thought in our head? How do we capture more sunlight, and how do we capture more water? So the argument always is, sorry, hopefully nobody saw that. The argument always is, okay, Joe, but the 4%. We got to have nitrogen, we got to have phosphorus, we got to have potassium, manganese, boron. So 78% of the air we're breathing right now in this room is nitrogen. And we have a wonderful plant species, they're called legumes, that form a relationship with rhizobium bacteria, and we're able to capture atmospheric nitrogen. So we got that one solved. But Joe, what about phosphorus? We're putting on phos every year. If I don't put on phos, the retail says nothing's going to grow. Anyone take a guess, 0 to 12, and I can see some people that were at my presentation this week, so you're not allowed to answer. 0 to 12, how much phosphorus is in our soil? Anyone do a soil test? Throw out a number. I'm literally not going to move on until somebody throws a number out. 10. Pretty generic answer. That's what shows up on my soil test under soluble phosphorus. 2,300 pounds of phosphorus, 0 to 12. This is 49 farms. It's a project done by General Mills. One of these 49 farms is actually mine. General Mills and Understanding Ag, they did this study. 2,300 pounds of phosphorus. Now, what shows up on a soil test is soluble phosphorus. That's what a plant can use. What's in the soil, most of it is tied up with calcium or magnesium. Now, nobody was fertilizing the land before we started intensive agriculture. Where was the plants accessing that phosphorus? How did they get that calcium, or break that calcium-phosphorus bond? It was the biology. And that's something that we've lost in the last 100 years. Everything we need to grow a plant is right there. What we're missing is the stimulated biology to actually go and access those minerals, break them down, and take them back to the plant. So I'm just going to tell you a little story about my first full season. So I can't see Keegan, but I've got an hour and a half to talk, and these are all new slides, so I'm a little concerned how long I'm going to go, but we'll give it a stab. So in 2017, I was going around to conferences, and there was a buzz about full season cover crops. I was fresh out of university. I knew everything there was to know about anything in agriculture. I was smart. Too smart, honestly. So I was going to these conferences and I was hearing this little bit of buzz of these full season cover crops where we mix a whole bunch of different species together, we throw them on the land, we don't use any insecticide, fertilizer, herbicide, fungicide, nothing. We use plant diversity to stimulate the biology and produce plant biomass. So, at this time, one of my very good friends and now co-founder of our company, Travis Avery, was representing a soil lab. And he graduated university the same time I did. The two of us together, we knew soil chemistry, we knew soil tests. So I told Trav, I said, I'm going to do this on this land. He was representing A&L Soil Labs. He said, I'd like to walk through the process with you and see what happens. This is very interesting. And I said, well, what do you think is going to happen? He said, based on this soil test, which has 6 parts per million phosphorus, something like 10 parts per million nitrogen. I said, what's going to happen here? He said, absolutely nothing. This is going to be a wreck. And I said, well, you're a smart guy, and I don't know any different. So I said, I think I agree with you. Oh, we're in a very high pH soil zone where I'm from as well. So I mixed some seeds together. I didn't know anything about anything. I ordered some, did some research online, mixed it together. Went out, sowed the crop. It was the last thing I seeded on an old hayfield that we'd broke up. This is 2.8% organic matter. It was some pretty harsh land, really light. Seeded it, and this is 20 days after seeding. This is what it looked like. So I didn't know whether this was good, bad, or indifferent, but it was about this time. My wife, my girlfriend at the time, she thought another woman was in my life, because every day I would come home, I'd grab a couple beer from the fridge, hop on the quad, and spend whatever I had left of the evening with this crop. Because everything that soil test told me was disproving, the crop was disproving that right in front of my very eyes. So every single day I went out, and it just kept getting crazier and crazier and crazier until finally I had to pick up the phone. And I'm like, Trav, come out and see this. I don't know what the hell's going on. 28 days after seeding, 6 parts per million phosphorus, we did not see one single mineral deficiency. No nitrogen deficiency, no phosphorus deficiency. All we saw was these healthy, diverse plants that were growing, and rapidly. So this is at the end, so we ended up grazing, not ended up, it was planned. We grazed our full season cover crop. That was the idea, to mimic Mother Nature with plant diversity and use the livestock to stimulate that biology, but really build soil and create a healthy soil ecosystem. So this is what the crop looked like at the end. Again, 6 parts per million phosphorus. It was at this point I knew that my life was going to change for a long time. Because my wife called this my second girlfriend. My second girlfriend was changing every single day, and I couldn't understand what was going on. Trav couldn't understand what was going on. So we knew this was something that was going to be important in our future to test and try and understand as best we can. So it comes back to this. Mother Nature's blueprint, trying to understand how Mother Nature grows plants. So we got 2 systems here. One has been growing on planet Earth. One system has been utilized on planet Earth for about 400 million years. One we've been screwing around with for a few hundred years, maybe 500 years, maybe 1,000 years. But let's talk about these 2 systems. So every single plant on planet Earth has a similar property. So when the crop is vegetative, or that plant is vegetative, it captures sunlight energy through photosynthesis, turns that atmospheric carbon into liquid carbon for plant growth, but something interesting happens. About 40% of that energy that plant captures, it releases into the soil. Why would it do that? Why would a plant that has the ability to capture sunlight, turn that into energy, why would it take half that energy and release it to the soil? To feed the soil biology. The plants, the soil, and the soil biology is what's known as a symbiotic relationship, meaning if one of those things does not exist, none of them exist. A plant captures energy from the sun. When it's in vegetation, it releases a portion of that energy, not just energy, hormones, proteins, to the soil biology, and it says, here biology, here's some food, now go get me phosphorus, go get me boron, go get me manganese. And that's the relationship. It's known as a symbiotic relationship. The plant can't survive without the biology, and the biology can't survive without the plant. So let's look at this beautiful, some would say perfect canola crop. Perfectly even, not a weed growing, and as you can see, it's flowering, so that crop's no longer in vegetation. It's hit reproduction, and those plants in reproduction stop producing root exudates. They stop feeding that biology. They say, thanks a lot for your help. Literally couldn't have done it without you, but I'm going to capture sunlight now, and I'm going to use it to produce seeds for my offspring. So in that canola field, where 100% of the plants are canola that have hit reproduction, no root exudates are feeding that biology. Well, that biology has to be there, or we can't grow plants. What is that biology surviving off of in the soil? Still carbon, but what do we call carbon in our soil? Organic matter. So if we're not feeding the biology is still going to eat, but it's going to start consuming the carbon that's in our soil. Now you multiply that by 100 or 200 years, and you see why our organic matter levels keep dropping and dropping and dropping. So let's move over to the Mother Nature's blueprint. which is what we try and mimic with cover crops, what we try and mimic on our farm, you'll notice there are plants that grow tall. Those plants have lignin in their stalk. They are a high carbon using plant. They need direct sunlight. So we have plants that grow up tall, capture sunlight, all the sunlight they need. But as well as high carbon plants, we have plants that have less of a sunlight need, that grow underneath the higher carbon plants and access sunlight and can regulate sunlight where and when they need. Another thing Mother Nature does is she has a diversity of plants with a diversity of life cycle. So some plants hit reproduction early, some plants hit reproduction later, but some plants stay indeterminate or vegetative throughout the growing season. By keeping an indeterminate plant or a vegetative plant growing throughout the season, we can keep the flow of energy from the sun to the soil biology, keeping that soil biology fed right throughout the growing season. So rather than consuming carbon out of our legacy carbon out of our soil and organic matter, we keep feeding that biology, keeping it healthy, keeping it active right throughout the growing season. So a diversity of plant species equals a diversity of root exudates, and a diversity of root exudates attracts a diversity of soil microbes. And when we have healthy, fed, diverse soil microbes, we also have healthy, functioning soil. And a healthy, functioning soil, as I showed you with the minerals that are in the soil, has no need for synthetic fertilizers or inputs because everything we need for life or for plant growth already exists there. So, living biology in the soil, although we can't see it, we can see it under a microscope. It is a carbon-based life form. It has the exact same needs that everyone in this room has. It needs water, it needs food, and it needs shelter or a place to live. So, just like us or our cows, where we try and have a balanced ration, think what are the two sources of energy when we're feeding a cow that we want to balance? We want to balance the energy, and we want to balance the protein. Well, when we're talking about soil biology, we don't call it energy and protein, we call it carbon and nitrogen. But just like a cow, if we fed a cow a diet of rye straw, that cow's not going to be that productive now, is she? If we fed a cow a 100% diet of third-cut alfalfa, well, you wouldn't want to stand behind her. When we take the rye straw or that corn stover and that vegetative cover crop like I'm holding in my hand there, we have the ability to balance that cow's diet. That's the exact same thing we're trying to do with the soil biology, is use diversity to balance the protein and the energy in the soil. So that is a balanced ration for that biology, and that biology is healthy and prosperous and has the ability to function, maximize productivity and function. And this is the result, a combination of all those things. So this is actually the good part of Manitoba. This is in the Red River Valley. This is $15,000 an acre soil. So on the left, this is the exact same spot, GPS reference spot. On the left, that is after a corn crop. So this is what 100 years of tillage and nitrogen fertilizer does to soil. So if you're a little bacteria living in that soil, where are you going to get air? Where does air infiltrate in that soil? Where does water infiltrate? Where does nitrogen infiltrate? Where is the surface area that you have to go around and access the minerals out of the soil that the plant needs? This soil is dependent on synthetic fertilizers because that soil is not functioning. So again, exact same GPS reference spot on the right. This is after high diverse full season cover crop. Those little balls in the soil are known as soil aggregates. So a soil aggregate forms around a root exudate. That's where biological communities live. The only thing that can create a soil aggregate, of course, is a deep ripper. I'm joking. It's biology. No mechanical tool can get a result like that. The only way we have soil that looks like that is highly, highly functioning and active, is if we hit those key steps. We have active biology, and we have a balanced ration. They create the pore space, so now we can infiltrate and store water. So I should have said off the start, I know this is a bit of an intimidating room, and I've spoken in front of a few, and there's not a ton of questions. But if anyone has any questions at any point, please raise your hand. I'll stop. If you're thinking it, somebody else is thinking it as well. Yeah, you betcha. 1 year. You betcha. And we're going to, Jason and I are both going to talk about water infiltration. I was going to talk about it here, but I think you guys are probably going to be sick of hearing it by the end. So I'll wait for a little bit later to talk about that. So a question I get lots is why so much diversity? So again, we're focusing on the 96%, and the first thing we need to do is maximize sunlight capture. We can't maximize water capture and retention until we maximize our sunlight efficiency and how we capture sunlight energy. So the dark blue, this is just an example of one of our cover crops. So the dark blue, those are known as cool season plant species. So the characteristics of a cool season plant species, they like water. They don't use water that efficiently, so it's nice to have lots around. They're frost tolerant, so we can get them in the ground early and prosper in cool conditions. But at 30 degrees temperature, a cool season plant shuts down. So they don't like direct sunlight. The light blue, those are warm season plant species. A warm season plant species has the opposite characteristics. They are crazy water efficient, so like a sorghum or a millet will use water 80% more efficiently than something like barley or oats. They're heat loving, so at 30 degrees a cool season plant is shutting down. At 30 degrees a warm season plant is maximizing efficiency. And obviously a warm season plant is not that frost tolerant. So we see these wavy lines. This isn't the last time you're going to see that. What we're trying to do is the light blue line, we do a switch here, is the ideal time for a cool season plant in our climate to be growing. So early spring, cool temperatures, lots of moisture, lots of growth potential, but as we get through the summer, hot and dry, cool season plants do not thrive under those conditions, but come later in the fall, ideally we're getting some moisture, but temperatures are cooling off, and we're back to ideal growing conditions for cool season plants. That big dark blue hump in the middle, that is the ideal growing conditions for warm season plant. So what's happening is when we mix this diversity together, what we're trying to do is take all the waves out and raise our worst case scenario or our bottom line by using plant diversity. Plant diversity is Mother Nature's insurance policy against climate and weather extremes.
Quick question for you.
Yeah, you betcha.
I didn't see all the fine print, and I just looking at that. I learned something today. You say is a C4 plant.
So say that again, sorry?
Buckwheat.
Buckwheat, you betcha.
Is a C4 plant.
Yeah, my dad's got a famous line because we grow buckwheat at home, which I highly recommend if you're a grain farmer. It's getting to be very, very popular in the American cover crop market, which 10 years from now is going to dictate, in my opinion, how we grow crops here. But my dad always says, don't walk by the buckwheat field with an ice cream cone because the whole thing will freeze.
Does that mean wild buckwheat? Is C4 as well? Because that stuff grows up here well, and I wouldn't consider that.
It is. But isn't it amazing how plants adapt to their environment? So if you've never seen what a cover crop blend looks like, this is the, I love always checking out new blends. This is what a 15 species cover crop looks like. And we're just going to go through some pictures from across Western Canada of different growing conditions we saw last year and what plants we saw and my best understanding of why. So this is in Milo, Alberta. You can't really see it, but there's an irrigation pivot in the background there. So this crop was seeded early May, cool soil. The soil was cool and conditions were just generally cool. Water was not a limiting factor here, obviously with the irrigation. I know you see some sunflowers in the canopy there, but virtually every other plant in that blend is cool season, even though they're warm season there. The most, just due to the conditions that were presented to the cover crop, conditions were most ideal for cool season plants. So those are the plants that propagated and consumed the canopy. So we're going to go extreme the other way. This is Edenwald, Saskatchewan. They had 1 inch of rain in the growing season. So we got Megan to stand in 2 different spots of her field, which each one tells an interesting story in my opinion. So this is a hilltop with no topsoil. And the right one, she's standing in a low spot where there would be runoff or some residual moisture from a previous year. You can see the light color of the plants that are growing on the hilltop. That is C4 grasses that are growing. A C4 grass is a lighter green color. We're going to see that lots in my presentation. And on the right, where there was moisture prevalent, there is obviously some warm season plants that are there just due to the dry conditions, but a majority of those plants being cool season. Yeah?
So I hear a lot of producers saying, well, I don't want to have any extra plants growing because they're going to use up all my water. How would you answer that question with that picture?
Well, you can't grow plants without water. That's a crappy way to answer it, but we want plants growing. And of course, this is not an ideal scenario. We need more than 1 inch of rain if we're going to grow anything here. But what I always say is have the right plant species in place, because nobody knows what the weather's going to bring that summer. So by utilizing plant diversity, we lower our seasonal risk because we don't know what the weather's going to do. So having the correct plant species there, we just see it time and time again, is so important. So this is actually a neighbor of mine. I found this just so interesting. So in Manitoba, in May we were dry, June we were drier, and July it was incredibly dry. So this is the mid-June on the picture on the left. They were incredibly dry, and the plants you see at the top of that canopy, those light green ones, that's sorghum Sudan grass. That is a warm season cereal, a C4 grass, and it is currently at the top of that canopy. And if I was a betting person, I would have said, by the time they harvest that crop, there's going to be sorghum that's 7 feet tall, and that's pretty much all you're going to see when you drive by. So end of June, I shouldn't say neighbor, these guys are about 30 miles from us. They actually did get some pretty good rainfall. And by the time this is on the right, this is the day they ended up cutting, all the cool season grasses had virtually came back and consumed what sorghum was there. So even within the same field and timing of the year, again, I'm always humbled by Mother Nature. I've been doing this for a long time. I've stood in hundreds of full season fields. Each one tells a different story, and I thought this was an interesting one. So I show this picture. I didn't show mine because we didn't get rain in July or August. And, well, August it did start to rain, but in July we didn't get any rain. And they had this was like a 5 bale to the acre crop, and we were pulling off 2. But it reminded me of a story my dad always says. He said, the thing about neighbors is rain, sex, and subsidies. The neighbor's always going to get more. So this is, I didn't show what this looked like earlier in the year. This is October. So we were brutally dry right through to August, and we started getting rainfall. So this group of heifers actually grazed this earlier in the year in July. And it was about this tall. So we grazed it, and it sat there for about a month until we started getting moisture. And this is a video, I believe. Yeah, this is kicking those heifers back out into it. Basically, every plant species was there. We don't ever see this. It was just the year that it was so dry early. And then when we did get rain, everything was vegetative and came back together. So again, just another testament to we don't know what's going to happen throughout the growing season. We were crazy dry early and got moisture late. And it was nice to have the diversity because literally everything came back. Yeah, and this is just a neat example. So this is dryland Saskatchewan, southern Saskatchewan. This was a trial. It was barley, oats, and peas on the left, and a full season cover crop on the right. So generally what we see, because you guys saw those humps of when cool seasons like to grow, so what we use in our blends for regrowth is Italian ryegrass, hairy vetch, berseem clover, and turnips, in the odd case radish. That's usually what we see because come fall it cools off and we get to have a bit more moisture. But in dryland Saskatchewan, where usually in July they don't get anything, you can see, again, the light color of those plants growing. Those are warm season plants. Basically, that is golden German millet that has come back. It was so dry and so arid there that when they did get some precipitation for the crop to come back, it virtually all came back warm season plants, which again, yeah, you betcha. Oh, not enough. I visit quite often. Like last year, they were under 3 inches, and they need an inch a week, pretty much. There is not much left for topsoil. It's a beautiful drive, though. If you guys ever get a chance to drive along the Saskatchewan border, heading either east or west, it's a gorgeous place. Just never rains. So a question I always get asked is, okay, but let's have the fertilizer conversation. Am I going to get away with fertilizer all the time, every time, no matter what? Well, that's not exactly true, but let's talk about kind of the science behind what's going on. So start with this again, because this is the key. If we can maximize the 96%, I mean, ideally it's going to be sunny unless we have forest fires or something, but if we can maximize sunlight capture with plant diversity, the next thing is water. If we get average rainfall or above average rainfall, where hydrogen and oxygen are not a limiting factor, we just generally don't see mineral deficiencies in our cover crops. Now, with that being said, on years where it is very, very dry, we are seeing some responses. So this is actually a neighbor of mine, a really good buddy. He went and sowed a warm season cover crop. You can see that's sorghum Sudan for the most part that you're seeing. Straight into a hayfield, which is a dry environment that crop's going into anyway. So on the left side of the line, he put 40 pounds of nitrogen down. On the right side of the line, he put absolutely nothing. So he texted me and he sent me the picture. He said, "What do you think is going to happen here?" I said, "Well, I think if it rains, probably both crops, I mean, the one on the right will come back, but if we don't get any more precipitation," I said, "well, the fertilized one definitely looks better." We didn't end up getting rain, and this ended up being, I think, somewhere between 20 and 30% increase in response from fertilizer. But again, that was we had virtually had, maybe an inch and a half of rain throughout the summer. So this is another example. You can see that strip right down the middle. So this is my cousin's place. We farm with these guys. So that was a fertilizer strip that I sowed. So this was 2022 when we were getting pretty decent rainfall. That strip, by year's end at harvest time, we saw no yield increase, decrease in the strip or outside the strip. So we do see generally early a response, and we've got third-party research that has confirmed this. Early on, when conditions are good, we'll see some response from a little bit of nitrogen or a little bit of phosphorus, but as long as we don't turn arid throughout the summer or just keep getting some rainfall, what happens is we stimulate that biology, we get that system functioning, and those spots just generally even out. Once we hit symbiosis, meaning we have a diversity of plants capturing sunlight, feeding that biology, the biology does its job and feeds that crop accordingly. So what have we learned in 4 years? So this is more our kind of third party, what we saw in third party trials. If you are going to use fertilizer, we have not seen any benefit of 150 pounds or 100 pounds or even 80 pounds. At 40 pounds on dry years, we are seeing some response with fertilizer. If you have a crystal ball and you know it's going to be a wet year, I would say you're 100% A-okay with no fertilizer applied at all. If you're using phosphorus, make sure you keep it 10 pounds to the acre. Too much phosphorus dissuades germination of legumes, but also mycorrhizal fungi forming a relationship with those plants. And mycorrhizal fungi, we're going to get to a little bit later, is the key to what makes this system tick. But something important to remember, not almost all, but a vast majority of our cover crop blends are sown without synthetic fertilizers, including on my farm. We've never used synthetic fertilizer outside of trials, just to make sure that we're seeing a response, or if we're seeing a response or not seeing a response. Phosphorus, because the high salt dissuades germination or hinders germination. Also, well, we'll get into mycorrhizal fungi right now if that's cool. So when a plant germinates, the first mineral it's looking for is phosphorus. Now, before we started applying synthetic phosphorus to our crops, what that plant did was form a relationship with mycorrhizal fungi, which is a fungal network that is like billions of years old, the oldest living organism on planet Earth. So as soon as that plant germinates and forms a relationship with mycorrhizal fungi, that fungi uses that hyphae network to go and access phosphorus. Now the problem with the high salt fertilizer is mycorrhizae doesn't want to touch it. So that's great. There will be a little bit of phosphorus there to get that plant going. And the idea is if we don't use 50 pounds to the acre or whatever, a high number, the plant can use that phosphorus. A decent amount of it will tie up with calcium or magnesium in the soil, and then that plant can form a relationship with mycorrhizal fungi. But part of the reason why I never use phosphorus on cover crops is because I want the natural system and the order to take place. So that plant germinates, forms a relationship with mycorrhizal fungi immediately, and then that fungi can start to build and break down minerals that are in the soil. Nope. Sorry, you're talking about rhizobium bacteria, I think, right? With legumes? No. We got to have legumes for nitrogen capture, like rhizobium bacteria capturing that. Rhizobium bacteria forms a relationship with those legumes, and that's how we get nitrogen in the system. Mycorrhizal fungi is, what's that? It's there regardless. Unless we're growing monocrop canola or a monocrop brassica, mycorrhizal fungi exists in every square centimeter of the soil. So what we're trying to do is, I mean, the cool thing about mycorrhizal fungi is it has the ability to form a relationship with the sorghum, the peas, the barley, and that communication network, it now works as a system rather than an individual plant trying to capture minerals. The forage pea has an ability to communicate with the oats, and the oats is saying, hey, forage pea, I need nitrogen, and the forage pea is saying, well, I need boron, so let's make that trade. And it's mycorrhizal fungi that facilitates that. Good question. Yeah, oh, yes, we inoculate with rhizobium bacteria, but we don't inoculate with mycorrhizal fungi. There is mycorrhizal fungi inoculants out there, and I have used them. On our farm, basically, we intercrop everything and are very cognizant and conscious about not screwing up our mycorrhizal fungi. So, yeah, so that's why we don't inoculate. I'm not saying it's a good idea, bad idea, I just don't know enough about it.
So in our monocrop systems where we can often put our phosphorus or our starting glands right with the seed,
Yeah.
we're deterring the opportunity.
This is a two-sided coin, and Keegan, where are you? You just got to give me a heads up if I'm taking too long in this. Here's what frustrates me so much about phosphorus. So many of us, I assume a large percentage of this room uses 1152 MAP fertilizer. So it's a water-soluble most phosphorus on the market are water-soluble. So as soon as that phosphorus is solubilized, it now has the ability to tie up. Now, phosphorus and calcium are made for each other. They bond almost immediately. So even when you go to your local ag retail, they'll tell you, yeah, you'll get 15 or 20% this year, but it's a next year fertilizer. Next year you're gonna get it. Next year you're gonna get it. So this year when you guys go to your retail and you hear that line, just ask them why. Why would that be? Why, once that phosphorus is tied with calcium, these things, calcium phosphate, really, really hard to break down. Why, once that phosphorus is tied up with calcium, why would it break down next year, or the year after, or the year after? So we've been over-applying phos forever and ever and ever. It does you no good putting 50 pounds to the acre, again, in my opinion. Because by the time that 50 pounds is solubilized, your plant doesn't need 50 pounds of phosphorus in the first month. It needs it when you're putting on vegetation. And by the time that plant is putting on vegetation, the phosphorus has been there for a few months, and there is a very, very good chance all of it is completely tied up. So now that plant forms a relationship with mycorrhizal fungi, if it's fungi dependent, and a fungi does a lot of that work accessing the 2,300 pounds we see in the soil profile. So phosphorus is a bit of an interesting one. We don't use it on cover crops. To be honest, we do still use it, some low salt fertilizer on our corn, but literally a small amount just to get that crop out of the ground, because I just don't see much value in a water-soluble phosphorus putting a lot on, because it's all gonna tie up. Anyone heard of field view mapping? Yeah, we just heard, it's been around for a long time. We just heard about it this year. I can't stress enough, this is free. As long as you've got a technology usage agreement, you can go to your local input. You can start getting data visualization of your farms, of your fields, 3 times a week, right through the growing season. Fertilizer's expensive, seed's expensive. It's a really good idea to know if it's working or if it's not working. And now with technology, we can see this in real time throughout the growing season. So, I mean, if you're trying cover crops, try some fertilizer. But let's see if the fertilizer is actually giving us desired results. If you're growing wheat and putting on 100 pounds of fertilizer, do a few strips at 50 pounds, do a few strips at 0 pounds. We have to start understanding these inputs better. They are so expensive. Can we be using them more efficiently? And now we don't need yield monitors on combines. We can just see in real time throughout the growing season where we are putting on more plant biomass. So this is a really great tool. I'm going to talk about it some more. What did it? Yeah, for sure. I got neighbors like that. So seeding and herbicide with plant diversity, I don't care if you're growing a Covers & Co. blend, intercrop on your farm, you're making your own blends. I don't care. This is the absolute key. 90% of how your cover crop, whether you're going to have positive results or negative results, happens at seeding time. There is a conception out there that because we're talking about mixing plants and less fertilizer and more insects and all the good, that these are somehow magic seeds that'll grow under any conditions no matter what. Nothing could be farther from the truth. When we're dealing in plant diversity, we're dealing different seed sizes, different seed coats, grasses, legumes, brassicas. We need good seed to soil contact, and what we're finding is that 3/4 of an inch to an inch with high diversity blends are the sweet spot, and we want even emergence. When we're talking about plant diversity, what we're really talking about is which plants have the access to capture sunlight to feed that biology. It does us no good to put 14 species underneath 90 pounds of oats. That is not diversity. 99% of the photosynthesis is going through an oat plant, and we're not stimulating a diverse biology. So what we're trying to achieve is exactly what you see in that picture there, which is different leaf architectures that have the ability to capture sunlight, that are the same height. So as we go through the growing season, all those plants have equal access to sunlight. And that's what we mean when we talk about plant diversity. It's where is the sun landing on a plant's leaf? Because that's what's going to feed that biology, and that's what's going to give us the most desired results. So the absolute key is take time at seeding time to do a good job. It'll pay dividends in the end. If you came to me and said, Joe, I love what you guys are doing. I'm going to buy 1,000 acres of cover crop and I'm going to broadcast it all. I'm not going to sell you seed because you're going to be really unhappy. Unless you get the absolute perfect conditions, you're not going to be happy with the results, and that doesn't do anyone any good. Take time and care at seeding time, and it solves a ton of problems. Yeah. Sorry, I was just going to skip over that without anyone noticing. Sorry. Glyphosate affecting biology. Well, glyphosate is not actually registered as a herbicide. Glyphosate is registered as an antibiotic. So what does an antibiotic do to biology? Not positive things, I would assume. Not assume, I know that. Glyphosate's a tough one. I struggle with it. I have read the studies. I have sat through the presentations. I have heard some of the predictions in the future. Here's my theory on glyphosate. You know, the fastest way to build soil is to stop losing soil. And basically, on farms, we've got 2 options as far as weed control early on. And that's tillage, which I'm just not willing to do, or glyphosate. Now, thank you for asking the question, because it's a good education opportunity. How many people spray glyphosate in this room? How many people know the ideal pH your water should be when you spray glyphosate? Nope. 4.5? Keegan and I have this argument. Keegan says about that, I say even lower is better. But we used to have a serious glyphosate problem on our farm, which was I was addicted to it and using 4 liters an acre on every single acre, and it was starting to not work. So we had a real problem. Tillage was getting to be an option. Lowering your water pH on your glyphosate makes your glyphosate work like you haven't seen it work in 10 or 15 years. It was one of the cheapest, best options we did on our farm is just lowering the pH of our water. Now, anybody? They said 4.5. I think 4.5 is great. The number I was told and use is 2.9 pH. Now, has anybody heard of fulvic acid? Yeah. So fulvic acid, what fulvic acid is, it's a carbon, it's got a high cation exchange, so it has the ability to pull positively charged minerals, attract it. Mixing fulvic acid with glyphosate is a really, really good idea for these reasons. When glyphosate hits a plant leaf, let's say you're doing a pre-burn or whatever, that plant recognizes glyphosate's going to kill me. That's going to kill me. So the first thing it does is it closes its stomata up tight so none of that glyphosate gets in. So with fulvic acid, when we chelate a glyphosate molecule with carbon, plant food or biology food, that glyphosate and fulvic acid hits the plant leaf. The plant recognizes that as food and keeps the stomata open. So we get more ingestion of the glyphosate, meaning we can use less. The other thing, and we're going to do some testing on our farm going forward, glyphosate residue is becoming a huge issue. I'm positive my farm is negatively affected by it, but when that glyphosate molecule ends up in the soil with fulvic acid, the theory is when glyphosate is without fulvic acid, no biology is going to touch it because it's a death sentence. But when we attach it to a fulvic acid molecule, that biology will now consume it, unbeknownst to it, because it thinks it's consuming the fulvic acid, and start the breakdown of that glyphosate molecule. Now, it is still a really, really long time that takes. But it's a better practice and better step as far as making your glyphosate more effective, using less, and actually starting the breakdown process in your soil.
And then can that get you on top of those weeds so that in the future you would not have to do that again?
That's the idea.
An annual practice necessarily.
The glyphosate practice? Yeah. It's the least bad thing I can do with my current practice. Yeah, all seeding widths. So I got 2 different drills. One's a 10-inch seed width, and one's a 6.5. But Keegan had a call from a guy a couple days ago. He's got a 12-inch. I like tighter rows because you close in that canopy quicker. I also understand that most of the people that are adapting these practices are either cattle farms or mixed grain and cattle farms, and they use what they got. Like 15-inch or 30-inch?
Well, the seed canola like 10-inch.
Yeah, I mean 10-inch, like my 8800 board goes at. I don't know. I don't think a corn seeder would work because you have so many different sizes of seed, and you got to have the right. Yeah, but I assume it's a canola plate that goes in the So no, I don't think this would work with this. Just the different. But I am not an engineer or understand new equipment. So uses on the farm, of course. So there was, lots of people understand you can use cover crops as dry hay. I add this in because when we first started, so many people were unfamiliar with the practice that virtually everyone just put it up for silage because they were worried about dry down time. This specific blend, this full season cover crop, there were like 60,000 acres across Western Canada last year, and I would say probably half was put up in dry hay, which is a little feather in my cap because it means farms are getting used to the practice that, hey, this isn't scary, this is basically green feed barley, and the dry down time's about the same. What I would say is just be cognizant, keep your swath rows wide, check the forecast if you believe it, and we V-rake a day or two beforehand when the top's cured but the bottom isn't. We check the forecast, V-rake it, and usually we're baling anywhere. I think I got 7 to 10 days there. That's generally where we're at. So silage, still lots of cover crops being put up as silage, but I'm going to use this opportunity to talk about sunlight capture. So just check out the crop in the background. You can see the sorghum sedan. It's probably 7 or 8 feet tall there. Sorghum is a C4 grass, carbon-loving plant. It needs direct sunlight and as much as it can. So the idea, we're trying to create a forest, is what we're trying to do. Trees are high carbon, they grow tall, they get access to all the sunlight they want. They are the kings, but in a healthy, prosperous forest, the trees aren't so tight that there's no sunlight getting down. So we try and spread out the trees, the sorghum, so they can get as much sunlight as they want, but at a low enough population that the sun can penetrate down another level. So you can see how tall the sorghum is, and about halfway down, there's full sunlight getting down to about halfway across. That's where our cool season grasses live, so think oats, triticale, barley, stuff like that. A lower sunlight need, so they can live underneath the sorghum, as long as the sorghum isn't too tight. But they can access enough sunlight because they have a lower sunlight need, even if there's a little bit of shade coming from the sorghum. Lower down in the canopy, it starts getting pretty dark down there. But that is where we put our indeterminate plants that have a lower carbon need, our legumes that also have a lower carbon need, and are also not constricted by upright plant physiology. So if I'm a sorghum plant and I want to maximize sunlight, I got one option, up. If I'm a hairy vetch plant right beside that sorghum plant, I don't have the option to go up, but if there's sunlight here, I can wind and weave and access sunlight here. So what we do with the indeterminate plants is the ones that aren't constrained by upright plant physiology, they are our sunlight scavengers. They have a lower sunlight need, and if they need to go get it, they have the ability to go get it. So what this means in a silage scenario is we're elongating our silage window greatly, because if we've got a monocrop barley field, we've probably got 3 to 5 days for ideal harvest timing. A crop like this, the barley might be ripe as hell in there, but because we've got living, growing plants, either vegetative or indeterminate, they have the ability to hold the moisture, and in the legumes case, that's where our protein in the blends come from, or our protein bump in the blends come from. So this was a Hutterite colony, Souris, Manitoba. So they harvested July 29th. This is 30 or 40 miles down the road in Darlingford, Manitoba. Same seeding date, 3 weeks later, or 23 days later, so over 3 weeks later, same exact moisture. But this is what's going on. So this is an extreme example of just 2 plants. You can see the sorghum, carbon-loving, needs full sunlight, grows tall, but the population is low enough so that vetch that you see can wind and weave and access sunlight wherever it is present. So, not that I'm a huge fan of a 2-species cover crop, but this just is a nice example of how the difference in those 2 plants and what we're trying to achieve. Grazing. So, I'm going to do a little shout out. Steve's actually coming on our webinar on Monday. We're going to talk about grazing cover crops. So this is what that looks like. These aren't my cows, but this is a neighbor of mine down the road. I got 2024 most profitable crops. So this past weekend, my brother and I were going through crop budgets, and damn, they do not look that good. So we were going through different options of what we could do. We've grazed cover crops since 2018. And the budget, now that the cattle market is where it is and grain is where it is, it looks like there's a bit of money to be made possibly, especially price insurance makes the risk a lot less, with grazing animals on arable land. So if you want to tune in on Monday night, I'm going to break down a canola budget at full and the profitability, and also break down a grazing background calves on cover crops profitability. And then we're going to have a conversation about how you do it, when to move them, intensity, stuff like that. So if you're available Monday night, check it out. Feed analysis. So a nice thing about, it's kind of like the silage, about utilizing plant diversity. People always ask me, well, what's the feed like? When do I cut it? And I always say, what's your goal? Like, what are you trying to achieve? You want the most digestible, highest protein feed that you can get? It's a good idea to cut that crop early. If you're a commercial cattle producer and you're worried about the haystack for the winter, leave it later. Capture all that plant biomass that you can. The trade-off is the earlier you cut it, the more opportunity you have for regrowth. The later you cut it, the less opportunity, obviously, you're going to have for regrowth. And the earlier you cut it, you get protein levels up like this. In the Interlake this year, where they had lots of moisture, we were seeing over 20. If you leave it till the start of October, you're probably going to see protein levels something like this. So will I see land improvements in 1 year? So I'm not going to show you this again, but I'm going to tell you a funny story about Gabe Brown. In about 2016, 2017, Gabe Brown was talking about his full season cover crop and how amazing the water infiltration was. He had land and cover crop the year before, and the next year he sowed corn. They had 3 inches of rain that night, and the sprayer that afternoon was out spraying and not making any tracks. And my dad and I looked at each other and rolled our eyes, talked about it on the way home. Well, that guy's full of shit. So anyway, a few years later, and I'm actively growing full season cover crops and doing water infiltration, which we're going to talk about more in detail. I had done water infiltration on this land, so just a little history. The year before, we had grazed a full season cover crop. We had phenomenal growth. We grazed it. We had rain. The crop came back. We grazed it again. And then the following year, we did a project with General Mills and the University of Manitoba, sowing cash crop right into that land, no fertilizer at all. So we did use some glyphosate to clean it up off the start. We sowed oat seed, and that was it. No synthetic fertilizer. But July 1st, 2020, you can see we had 3.5 inches of rain overnight. And because I had done the infiltration test in this land, I knew the water infiltration was phenomenal. This is me out, my chicken legs out walking there. This is the following morning. So there wasn't a puddle on the field. I had my bricks reader. I took some leaf samples, and that crop was literally photosynthesizing the very, very next day. So, any questions? Water infiltration, anything? Cool. How am I doing for time, Keegan? An hour? Okay. I'll speed up the pace here. So a practice, again, we're talking about maximizing sunlight capture, water capture. I think this is a really, really great opportunity, something that's probably underutilized in the prairies for producing cattle feed, which is using plants in their proper context to try and harvest 2 crops in 1 year. So I told you this graph's coming back. So we're going to use this fall as an example. So I got an arrow right here. We're about, say, the end of August, something like that. We've got that little hump of opportunity for cool season plants. A nice opportunity, in my opinion, in fall. Fall-seeded annual crops I have had not much success with, but we do have some wonderful plants like fall rye, winter wheat, triticale, hairy vetch, red clover that has the ability to, once established, overwinter and grow in spring. So this is a producer that had that exact blend. This is in fall. Now I know a lot of us are cattle producers and that looks awful tempting to kick the cows out and graze it, now doesn't it? Not a good idea if we're wanting that crop to overwinter. And if we're going to successfully do a double cropping, we just have to leave that going into winter. So it's well established, so we're not going to get as bad of winter kill going into next year. So winter has gone by. We're now later in the spring. So this is maybe mid-June, could be end of June. The crop's going to look something like this. So we have an opportunity, again, basically at this point in the cycle, we're living off wasted sunlight and water. So we captured sunlight and water later in the fall, heading into winter. We captured sunlight and water earlier in the spring when it was available. Conditions are most ideal for cool season plants. So we can either take that crop as dry hay or silage or graze it, but first harvest will be done either mechanically or with the cows. So now that brings us to the start of summer. So we'll call this July 1st. The big blue hump is coming in the middle. That is most ideal conditions for warm season plants. So if we're going to, after that crop's harvested in June, we got lots of time to grow some more plants. What are we going to put in as far as species? Well, we're going to put in warm season species, right? So C4 grasses, a little bit more information. So you can see German millet and sorghum Sudan there on the right. C4 plants are more water efficient, like I was saying, drought tolerant than C3 plants. The optimum daytime temperature is 30 degrees and above. So 30 degrees and above a C4 plant is maximizing sunlight capture. 30 degrees and above a C3 plant is shutting down to nothing. C4 plants have a waxy leaf surface that reduces water evaporation from the leaf. As you can see, the shine. That is, so when the sun hits that leaf, that plant is reflecting that sunlight back rather than absorbing that sunlight and having to use water to cool it. So a neat, cool evolutionary trait that we're going to talk about in a little bit here. So this is what, this is actually from my place in 2023. This was the heat of the drought. This crop was hanging on. It looks pretty good in the picture. I swear, I'll tell you, it looked a lot worse in person. But that takes us to here. So now we're later in the fall. Let's call this September 1st. We've got a crop, ideally, that looks something like this, or something like this. So this was actually that picture you saw of the cows grazing earlier in the spring. This is what this crop turned into after he kicked the cows off. Whoops. I'm going to talk a little bit about what I did with my double crop this year. So my wife loves it when I use that picture of her. Fortunately, she's not here. So we utilize this for extended grazing. So we seeded this on July 1st. We grazed October 8th to October 15th, roughly. I was going through my phone checking dates here before we started. Unfortunately, all the cows didn't behave. They didn't all come running when I opened the gate. A lot of them were a half mile away. But this is what we were trying to achieve, is a residue mat on the surface, good intensive grazing. I don't know if we hit the take half, leave half, but this was most ideal for us to keep that soil covered. Fortunately, we've got a zero-till disc drill, and we'll seed directly into this next year. Anybody utilize swath grazing? Tried swath grazing? So here we're going to talk a little bit about the advantage of warm seasons and what this waxy leaf offers from a swath grazing scenario. So that shiny leaf that is good for reflecting sun and keeping that plant cool works really, really great once that crop is in a swath for shedding water and holding quality of the plant biomass that we're wanting to stay good for the cows to graze later in the year. So an advantage of the warm season is you're seeding it later, so we're putting it in a swath later, but then once that crop is in a swath, because of these waxy leaves, it just sheds water really efficiently, not negatively affecting the quality of the biomass when it rains. So this is an example from 2021. We've had a couple dry years. So if you look down here, you can see a couple green plants poking out. This has actually been seeded for, June 30th. This would be like 20 days. We had 16 millimeters of rain at this point. This is a month later. We had about another ½ inch of rain, something like that. But at this point, the grasshoppers had moved in. 10 species blend, and they had wiped out 9 of those species completely. The only thing that was left standing was sorghum Sudan, and we've seen this quite a few years in a row now that grasshoppers do not touch sorghum, and thank God, because in 2021 we needed it. So 29 millimeters of rain. The other thing is a warm season plant. It can really take the heat, and it needed to because it was getting hot and there was no moisture. Again, it's a vegetative plant. So if and when moisture was to come, we can get a crop that turns into this. So you can see 143 millimeters, same thing. In August, it started to rain, and this crop absolutely took off. So he took this picture. This is the day he was swathing. This is what the swath grazing looked like, and something that, if you guys aren't familiar with sorghum, I'm going to make it my mission to make it popular in Western Canada. It's an amazing plant. Not only is it high in energy, it's got a lot less lignin than corn. It is much cheaper to grow. There's some studies coming out of the States that sorghum Sudan actually acts like a legume in that it forms a relationship with free-living nitrogen bacteria, so you can get away with a lot less nitrogen. Just a really versatile plant for growing plant biomass for cows. Yep. Prussic acid, good question. So prussic acid, if you guys have heard that with sorghum, and I got to stop saying sorghum. This is sorghum Sudan. So when we get frost in the fall, if it was straight sorghum, the cells in the plant burst, and it releases prussic acid, and prussic acid is toxic to cows. Now, when we cross sorghum with sorghum Sudan, the prussic acid risk comes down significantly. Not zero, but comes down like 90% the risk. But what we tell farmers, if you get a frost, or not if you get a frost, when you get a frost on the sorghum, just don't, if you can keep cows out of there from anywhere from a week to 10 days, just to be safe, the prussic acid, it gasses off. You can bale it after a frost, you can silage it, as long as you're not feeding it to a cow, you know, a week after a frost. To this date, we have not had any issue with prussic acid. I'll tell a quick story. 2021, the only regrowth I had on my home quarter was basically sorghum Sudan. I had 8 cull cows in the corral and a frost that night. So I thought if anyone's cows are going to die from prussic acid, let it be mine. And I kicked them out. I didn't know what to expect, but there were no ill effects at all. So I think if you're doing research on sorghum, you'll see a lot of the prussic acid scare. Anything that you're going to do with sorghum, it's going to be a sorghum Sudan cross, because the Sudan part of it makes the plant a lot leafier. You don't have an interest in growing straight sorghum. So I should say sorghum Sudan when I'm talking about the plant. Yeah, and people always ask, oh, what about the residue? What's it like seeding into next year? So this is us seeding into that exact swath grazing we did. We didn't even see no residue humps. There was so much manure down those rows, I thought we might see an inverse hump, but we didn't see anything. It was smooth across the field, no negative effects from whatever residue was left over. Yeah?
What about just not swathing it, just grazing in the winter and the snow? Without having, like, just like grazing grass?
Yeah, so this year, as long as you're not getting snow, absolutely. You can get away with it for sure. When you do get frost, I mean, the quality of that crop comes down. I mean, sorghum's pretty resilient. It holds a decent amount of its minerals even after a frost. I always worry about snow. With that being said, bison guys, like a lot of bison guys, are using our warm season blend and just grazing it. In a year where you got 2 feet of snow, I don't know how much you'd lose. Maybe 30 or 40%, something like that. I like the idea. I don't love running a swather, but I just do it to just guarantee that I'm going to have the quality there, basically, and that they're going to get it all.
Isn't the turnip, they eat the turnips too?
Like in swath grazing or regrowth?
Yeah.
You betcha, yeah.
They'll pull them out of the ground.
So the turnips, they like the leaf. The actual turnip bulb is the last thing of the 15 species that they like to eat.
These guys still do.
So, turnips, you betcha. Yeah.
I mean, with the ground frozen, they're still,
But yanking them out. Yeah.
there's no snow.
Yep. This was our swath grazing webinar. This went, as the kids say, viral. In the cover crop world anyway. There's quite a few views on this. If you guys are interested, so I've swath grazed for years, and I learned a ton from these 3 producers that have been doing it a lot more effective than I had. So really great conversation. If you guys check out our YouTube page, it's about an hour and a half long with just a wealth of information. Anybody grow corn? Yeah. If we were in Manitoba, the whole room's hand would go up. But I'll talk a little bit about some of the intercropping that we're doing with corn. So I've been growing corn for years. We've grazed it, we've silaged it, we've combined it, and every year I try and intercrop something. We weren't having a ton of success because with corn, if you sow an intercrop at seeding time with the corn, you don't have a herbicide option, and corn is pretty wimpy when it comes to weeds. And if we're going to spray the corn and come back at V5 and seed a cover crop between those rows, 96% of a plant. Again, we put a seed in the ground when the corn's this tall. By the time that seed's this big, the corn is this tall. And now that little seedling's got to fend for itself as far as finding sunlight and water, and it doesn't really work. I have never done it, and it's been worth my time to this point. So 3 years ago, we imported some long season forage soybeans, Roundup ready forage soybeans from South Carolina. And the idea was I was just going to seed soybeans, corn with the 30-inch rows, seeded north and south, and then solid seed beans right behind. And we didn't know what we were going to see, but the results were pretty cool. So this is a very good friend of mine who, this is the first year we tried it. He did 60 acres. A vast majority of the soybeans and the corn is done exactly what you see here in silage. There's a lot of opportunity for increasing protein, not to mention green plant sunlight capture right throughout the year. So one of the things that I think is super cool, because I've seen lots of silaged corn crops, monocrop corn crops, and it just looks like a destitute area of these sticks sticking out of the ground. But with the intercrop, with the long season bean, that crop is lush green even after the harvester has been off the field. So, going to come back to field view here. I got my brother-in-law is a high up at Pioneer, and we go back and forth about intercrops. He cannot understand why I'd want to grow an intercrop with corn, and I don't understand why you wouldn't. So we don't even talk about it anymore, but the common consensus with corn is corn's a wimpy plant. Corn can't take any competition. Anything you grow with corn, all you're going to do is reduce your corn yield. Why would you want to do that? Corn's expensive to grow from a fertilizer standpoint, from a seed standpoint. Well, thanks to FieldView this year, so these are two pretty, or the funnest examples that I like to pull out. 100% of our FieldView data, and we've probably got a dozen now, is showing increased plant biomass where corn is, the corn is intercropped with the beans. Every single trial we did, we saw an increase in total plant biomass yield. So on this one on your guys' right here, so that's just west of me, they had like 2 inches of rain. That crop was horrendous, but you can see exactly where the beans were even on a dry year. This one on the left, this was a dealer of ours who's they sell all sorts of seed, lots of corn seed. So this was corn and forage soybeans up against all the newest varieties of corn. So you can see them in strips, and you can see which one was the intercrop. So from a straight production of biomass standpoint, it's looking like this is an absolute no-brainer if you're putting it up for cattle feed, because we're increasing our total plant biomass. And I think I got this. This was a trial we did in 2022. I got to update these. I should have done it before this. We've got new data from this year. But on this trial, it was 9.5% protein on the intercrop, and the monocrop corn was 8. But we're hearing some stories from where there was good moisture west of Red Deer this year, that we were seeing protein increases of up to 3% and total tonnage increases of up to 3 ton. Yeah, that is a good question. I actually, come up and ask me sometime today. I'll have that data on my laptop. Yeah, so those soybeans, I'm going to get to that question when I talk about nitrogen, if that's cool.
Okay, I was going to ask about how you manage fertility.
Yeah, good question too. Yeah, I think I've got it right here. Okay, so we're going to talk about the length of soybeans. So if you guys can see this, that is my cousin's just monocrop grain soybean. This is what a monocrop soybean looks like the start of October, southwest Manitoba. The green ones are obviously the long season forage soybeans. So those beans do not hit reproduction for 110 days. So that little bean right there, the brown one, because it needs to be a short season, it needs to produce seed. When that plant hits reproduction, it's about this big. So that plant maximizes nitrogen capture 45 days after seeding, and it's about this big. Those forage soybeans will not hit reproduction in our climate, meaning for 110 days or however long they're growing for, they are capturing sunlight energy and releasing a portion of that energy to the rhizobium bacteria, and that rhizobium bacteria is responsible for capturing nitrogen. So rather than having a little plant like this capturing N for 45 days, we've got a beast, a nitrogen factory that's able to capture sunlight throughout the entire growing season. So this is what, it's actually really hard pulling these these roots out of the ground and actually getting the nodules to stay on. Some of these were as big as quarters, but this is a video of what the forage bean looked like. I hadn't seen anything like it, nodulation like that. So this is the same plant on the right, and then I'm just going to pan down to what the roots look like on the conventional grain soybean. You can see the nodules on there are brown and dead. It's because this is the start of October, and those nodules haven't been getting energy since the start of June. So that plant hasn't been producing nitrogen since the summer solstice, again, about 45 days after it was seeded. We're going to talk about fertility, right. So what does that mean for residual nitrogen? Well, it's very exciting. I'm a bit of a plant nerd, but we did 3 different trials of 30-inch corn. The average on the 3 trials was 27 parts per million residual nitrogen, which works out to 54 pounds per acre residual nitrogen after growing a corn crop. This is where we're doing quite a bit of research this upcoming year, and I'm very excited about it. Not 60-inch corn. We don't get enough sunlight to make this a viable option from either a silage yield or a grain yield in any way. But look at the parts per million nitrogen, 49 parts per million after growing a corn crop. That's 100 residual pounds of nitrogen for next year's crop. So we're going to do some trials, try some paired row corn and just a little bit wider rows to see if we can not affect the corn yield, but also get this residual nitrogen number up. Now, to answer your question, I am not recommending a fertilizer reduction on year 1. We just don't have enough data to say that that is a good idea. We have producers that went full bore. They hate paying the fertilizer company, so they just said, screw it. I'm growing the beans and I'm growing the corn and I'm not using anything. And there were some interesting results. They weren't hitting the numbers that fully fertilized crops were. On our farm, we only use about 40 pounds of nitrogen on our corn. But don't leave here and say, I'm going to cut my nitrogen in half. We want to test it and see. Because part of the issue is, these beans, if you feed them 150 pounds nitrogen, they're just going to use the free nitrogen that's there, and they're not going to form that nodulation. So currently, it's a bit of a dance. How can we get nitrogen to that corn crop when it needs it without these beans just sucking up the excess? We want that nodulation, and the more and more and more fertilizer we put on, the less nodulation we're going to get. Whoops. So I just want to talk a little bit about my corn crop this year. This was a shit corn crop, and yep, sorry. Yeah, yes, like not hard data, just like I do lots of these trials on my own farm, and I use not ESN, but coated nitrogen. And I'm always out there like digging up like the soybeans to see which is nodulating first, because we do like 0 nitrogen trials, 50% nitrogen trials, then 100 pounds nitrogen trials. And definitely the beans with no fertilizer at all, they're nodulating earlier, but not as early as I would have thought. Sorry, I'm coming. The difference was only less than 2 weeks. The stuff that had 0 fertilizer and the stuff that had 100 pounds of fertilizer. It's a complicated one, and it's just one that's going to be settled with research, basically. We just don't have enough data currently to say, yeah, ESN is going to work 100%. I can make an argument in my head why it would work, and I can make an argument in my head that it's just going to slow release throughout the year, and the beans are going to take advantage of it and not nodulate. So, good question. I'm sorry about the indecisive answer.
Are you inoculating your beans before you put them? Single inoculation, double inoculation?
Single inoculation, just a powder. And I think in Manitoba we could get away with nothing, because every May the sky is black with topsoil from the soybean land that they've rolled. Here, where soybeans aren't as prevalent, I would inoculate for sure. So. No, the risk is you'll just get nothing. So because I I had started, like with my intercrop, using just regular conventional beans, like a little bit longer season grain bean. But what happens is as soon as that plant hits reproduction, so again, that's about the summer solstice here, that plant hits reproduction, its sunlight need goes skyrockets. It needs energy to produce seed, and what's happening is it's underneath a corn canopy, so basically the plant stops becoming vegetative, and when it's this big, it just kind of, it tries its best to produce seeds, and it just stays about this big. The advantage of keeping it vegetative is the sunlight need is so much less, and that way the plant stays alive and grows until the corn's uptake drops, and then that's when the soybeans growth promotion really takes off. 10 minutes. I'm not going to get done in 10 minutes. Well, I'm assuming he's worried about lunch. So we were crazy dry. We had a bit of rain in May. June 14th we got 4/10 of rain, and we did not have any rain for 54 days. This crop of corn, I was hounding crop insurance to write off because I was going to need cow feed this winter. So what happened is the corn wasn't super. The corn ended up yielding about 100 bushels to the acre, which was way better than I thought. But by August, the corn was pretty much shutting down. It was onion leafed. It looked horrible. The beans looked even worse. Grasshoppers were starting to move in. They were this big. Anyway, come August, we started getting rain. And because those soybeans were vegetative, they captured the rainfall and they started to produce leaf biomass. So this was the day we combined the corn. So what we do is we don't have a dryer. We're not really set up to handle that amount of bushels. We combined the corn and then sold it to a feedlot as wet corn. So we took it at 30%. So we were able to get it off earlier. And my biggest motivation was getting it off so I could kick the cows out and grow it. So I have $1,000 an acre in a drought. This is a no-brainer, and I know there's not a lot of grain corn being grown around here, but there's getting to be new varieties, and this is the easiest slam dunk we do on our farm. So we seeded May 25th, combined on the 10th of October. We grazed 200 pairs October 15th to January 1st. So it worked out. I got some pictures here. This is what the crop looked like when we were combining. You can see the corn is dead. It got hit by frost. The beans are still green. So an interesting observation we've seen is the corn protects the beans. Anywhere there's beans in the corn, the beans are not affected by -1, -2. But if there's beans without corn, it'll get nipped by frost. But yeah, the beans were still green when we combined it. So we kicked our cows out. The grazing numbers worked out to 100 cows, and this is just cows, even though we had calves on them as well, 100 cows per acre per day. And I value that at $3 a day, which is my winter feed cost, so an added value of $300 an acre from the grazing standpoint. And this is just a cool story. I won't take too long. So the cows are grazing. You can't really see them, but we had the snowfall, and we were going to ship calves. This is end of November sometime. So I thought, well, I don't want the calves to lose condition before we're going to sell. So I went and I took 40 hay bales out to the cows, thinking when I was unloading these bales, they know the sound of the tractor, they know what a bale looks like. I was going to have 200 cows and calves surrounding, consuming hay. They did not even look up. They didn't take one step towards me. And they had been grazing this for almost 3 weeks. So cows like to graze as long as they've got something that they can eat and have a balanced ration. Oh, nice. I'm going to finish in 10 minutes. The last thing, I'm not going to talk a lot about this. Perennial hay is not my wheelhouse. However, we have partnered with Interlake Forage Seeds. They've been doing forage seed production for 40 years. If you're not familiar with Manitoba, a lot of the forage seed that's produced for Western Canada happens in the Interlake, between Lake Manitoba and Lake Winnipeg. So we've partnered with them to come up with a few different blends that look like this. I won't go through them in great detail due to time constraints, but we've got a dry land, or a light land hay, which is essentially more alfalfa for regrowth potential for second cut or grazing in dry areas. And then we've got a much more diverse wetland perennial hay blend 3 different types of alfalfa, a variety of different legumes. Sandfoin and trefoil are non-bloat, so make for a nice ration to lower the risk of bloat with all that alfalfa. Yeah, if you got any questions on this, just come up and chat with me after. I think Jason's going to talk a little bit about some funding. Yep, okay, cool. So I won't touch on it, but just it's a great time to be getting into or get interested in cover crops. I mean, we've got these ones posted. These are the big ones, but there are new organizations popping up every day that have funding for cover cropping. It really lowers the risk, and you know, back when I started, I was just doing it on my own dime and my own curiosity, and there were some wrecks, but this really takes the risk out of it and the pill a little easier to swallow. In Alberta here, it's like 80% of your seed cost can be covered, so make sure you're taking advantage of that. And that's my last slide, so if we'll take questions quick, or you want me right off, Keegan? Okay, any questions? Yeah, you betcha. Oh, good question. I don't want to tell you the wrong one, but I got it on my laptop here, if that's cool. I'll find me sometime today. Increase. Oh, like on just the corn? We see an increase total biomass, so like the corn and beans together, we have just seen increases. Even in dry. Yeah, yeah. So one of those field view maps that I showed, they literally had less than 2 inches of rain in the growing season, and like the field view data was clear right throughout the year. It was obvious where there was more plant biomass. So probably what's happening is your corn's probably a little bit less, but it is made up from the intercrop. Last chance? Yep. Alfalfa with wheat?
Yeah. Why doesn't people do that in Canada? I know the winter is much more strong here, but I'm talking of rainfall of 2 to 3 inches a year, and it's not soil like that, it's rocks.
Yep.
Like you go to the Southern Cape, they grow canola crops there, but most of the farmers also sheep and cattle farmers, but they do, I know it's with the wheat and barley and oats they put alfalfa in, and a few of them also start now to do intercrops, or they call it intercrops. It's basically you take a portion of wheat, a portion of oats, and a portion of barley, and you still seed it together, and then you just separate it at harvest with the screens. Is that something you focus on in Canada?
Oh yeah, I intercrop, like on our grain side, we intercrop everything. Like forage peas and oats are a phenomenal one, getting more popular as again, the American cover crop market, every 2 years it doubles. And they are demanding cool season crops, and we grow cool season crops here. I think in 10 years it's just going to be a huge market that a lot of grain farms are going to be utilizing. To answer your question about the alfalfa, I do that on my farm. I mix red clover and alfalfa underneath our oats. The reason people don't do it is because you tie your hands from a herbicide option. I do it because if it's a huge wreck and it's weedy, I'll just cut it for cattle forage. But if you're a grain farmer, hey, I'm with you. I think it's a great idea. Tough sell for a grain farmer, but it is a good idea. Yeah, South Africa is we talk about these like they're new ideas, but you guys have been doing it for 30 years. You're the OGs. One more? Okay, I'll get off.
Thanks, Joe.